Yes. Hi my dear students. In the previous videos we discussed types of matrices. So in the types of matrices, while explaining these types of matrices in this concept, before that I explained this also. That is the elements in general. If a matrix is of order m cross n, then the matrix generally we will write like this. The elements in this matrix will be like this. That is A11, A12, A13 up to so on A11, 1n. I am writing in this. What it indicates then? So as earlier I told, A11 means what? The element. This will indicate the element of the first row, first column. So that I am writing A subscript 11. A subscript 11 means what? First row, first column element. First or second column element A12, first or third column element A13, up to so on. I am writing here it is A1n. A1n means what? First row, nth column. Therefore, I am writing, why I am taking n column here? It is because I am writing the matrix of order m cross n. So m cross n is the order of the matrix, means what it indicates? In this matrix, m rows are there and n columns are there. So therefore here it is n columns must be there. So therefore I am writing A1n. And also we discussed the elements A11, A22, A33. These all we can call it as the diagonal elements that we discussed in the previous videos. That is the A11, A22, A33. Whatever the elements lying in the diagonal. So normally we know what is meant by diagonal. So whatever elements lie in the diagonal line, so those all elements, that is A11, A22, such a type of elements, A33, these all elements we can call it as the diagonal elements. My dear students, this we discuss. So this we can call it as the diagonal elements. Clear? And next, the whatever elements above the diagonal elements, whatever the elements are there, and this we can call it as the diagonal elements. And after that, in this line, the wherever the diagonal elements line, those line constitute, or those line we can call it as the principal diagonal, we can call here this. So what is that? Principal diagonal. Or also you can, but this in short I am writing it as PD. So what is mean by PD here is the diagonal elements on the line through which the diagonal elements are lying, that we can call it as the principal diagonal, we can call, or also we can call it as the leading diagonal also you can call. So leading element or leading diagonal we can also call it. This information we know. And this is the in word or in sentence form we will write like, we will tell like this. But in mathematical form, how should I write here this? So if A is equals to Aij, if I write, this is the matrix of order m cross n. So in general, either we can write like this, the within the bracket elements we can write, or we can write this is the compact form of this whatever I wrote here, this matrix is, in short I am writing. So this is the compact form of the general matrix of the order Aij m cross n. So the both are same only. This is the compact, this matrix is the compact form of this, is it? So therefore either you can write like this to denote a matrix of order m cross n, either you can denote like this, or you can write like this. And this we discussed in the previous video. And also my dear students, if I write Aij is equals to m cross n, that I will write here it is, and here it is. If Aij is equals to, here it is, Aij equals to, here it is, Aij, or else Aij for I not equals to j. A is equals to Aij for I equals to j means what it indicates? Aij for I equals to j means the row and column value must be same. That is, this is possible. A is equals to Aij for I is equals to j. So I and j values must be equal. Such elements A is equals to Aij for I is equals to j means this is nothing but the diagonal elements. This indicates that A is equals to Aij for I is equals to j means what it indicates? It indicates diagonal element. Why it is so? because A is equals to Aij for I is equals to J means what indicates I is equals to J. Row and J column, row and J column always equal in this place. That is A11, A22, A33. So therefore this we can call it as diagonal elements. So in the context, if I write Aij is equals to A is equals to Aij for I is equals to J means you should understood that yes, this is nothing but the diagonal elements. Like this you should think or you should assume. And next, if I write Aij, A is equals to, this is common, A is equals to Aij for I less than J. If I write I less than J means you should assume that I is less than J means here it is I value is less than J. Is it here or here? I value is less than J. It means that I value here, this is I value. Here I value is 2 and J value is 1. So I is less than 2. In this case I is not less than 2. I less than 2 is here in this case. 1 is less than 2. Is it? I is less than 2 here. And next I is here also I is less than 2. I is less than 1 is less than 3. 1 is less than 2. 2 is less than 3. So therefore my dear students, you can observe here, if I write A is equals to Aij for I less than J means you should assume or you should think that these are the elements which lying above the principal diagonal. So this we can write here, it is above the principal diagonal. Above principal diagonal. Clear, my dear students? So what is that? If I write A is equals to Aij for I value is less than J means you should assume that these elements lies above the principal diagonal. And next, my dear students, if I write A is equals to Aij for I value is greater than J. If I value is greater than J means again you can observe I value, where the I value is greater than J? Here 2 value is greater than 1. Here 3 value is greater than 1. 3 value is greater than 2. So therefore you can observe here it is all the elements which lie below the diagonal, all those elements satisfies this condition. What is that? A is equals to Ij for I is greater than J. So therefore if I write A is equals to Aij, A subscript Ij for I value is greater than J means you should assume that yes, these are the elements which lie below the principal diagonal. Like this you should assume. So this is very important concept. Why I am using or I am explaining this, because we need further future. In future where if while discussing the definition or sometimes while solving the questions, they will give you these conditions. A is equal to Aij for I is less than J. In that case, you should understood yes what it means. What is the meaning of I is less than J? In such a cases, you require this information. So therefore, I explain. And in the last video also, I discussed this. After discussion of this only, I discussed some types of the matrices. So my dear students, I hope you understood. So I'll explain in once in Kannada. So now suppose ಯಾವುದೇ ಒಂದು ಮ್ಯಾಟ್ರಿಕ್ಸ್ A is equals to ಯಾವುದೇ ಒಂದು ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಆರ್ಡರ್ m ಕ್ರಾಸ್ n ಇತ್ತಂದ್ರೆ ಅದನ್ನ ನಾವು ಹೆಂಗ್ ಬರಿಬಹುದು ಅಂತ ಹೇಳಿದ್ರೆ ನಾವು ಈ ರೀತಿ ಬ್ರಾಕೆಟ್ ಒಳಗಡೆ ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನ ಬರಿಬಹುದು. ಸೊ ಈ ನಮಗೆ ಏನು ಈ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಈ ರೀತಿ ಬರಿಬಹುದು. ಸೊ ಇದೇನು ನಮಗೆ ಇಂಡಿಕೇಟ್ ಆಗ್ತೈತಿ ಅಥವಾ ಏನಿದೆ ನಮಗೆ ತೋರಿಸ್ಕೊಡ್ತೈತಿ ಅಂತ ಹೇಳಿದ್ರೆ ಈ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಲ್ಲಿ ಇಲ್ಲಿ ನೋಡಿ ಇಲ್ಲಿ ಎಷ್ಟು 1 2 3 ಎಷ್ಟು m ರೋಸ್ ಇದಾವೆ 1 2 3 4 ಅಪ್ ಟು ಸೋ ಆನ್ n ಕಾಲಮ್ಸ್ ಇದಾವೆ ತೋರಿಸ್ತಿದೆ. ಸೊ ದೇರ್ಫೋರ್ ಯಾವುದೇ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಇದು ಆರ್ಡರ್ m ಕ್ರಾಸ್ n ಇತ್ತಂದ್ರೆ ಅದನ್ನ ನಾವು ಈ ರೀತಿ ಬರಿಬಹುದು, ನೊಟೇಶನ್ ಈ ರೀತಿ ಬರಿಬಹುದು ಅಥವಾ ನಾವು ಈ ರೀತಿ ಬರಿಬಹುದು. ಸೊ ಎರಡರಲ್ಲಿ ಏನೂ ಡಿಫರೆನ್ಸ್ ಇಲ್ಲ. ಜಸ್ಟ್ ಇದು ಬರೀಲಿಕ್ಕೆ ನಮಗೆ ಕಷ್ಟ ಆಗ್ತೈತಿ ಅಥವಾ ನಂಬರ್ಸ್ ಎಲ್ಲ ಪ್ರತಿ ಸರಿ ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನು ಬರೆಯೋದು ಸುಮ್ಮನೆ ವೇಸ್ಟ್ ಆಗ್ಬೋದು ಅನ್ನೋ ಉದ್ದೇಶಕ್ಕೋಸ್ಕರ ನಾವೇನ್ ಮಾಡಿದ್ದೇವೆ ಕಾಂಪ್ಯಾಕ್ಟ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಶಾರ್ಟ್ ಆಗಿ ನಾನು A is equals to Aij m cross n ಅಂತ ಬರೀತೇನೆ. ನೆಕ್ಸ್ಟ್ ನಮ್ಗೆ ಗೊತ್ತಿದೆ ಸ್ಟೂಡೆಂಟ್ಸ್ Aij ಅಂತ ಹೇಳಿದ್ರೆ ಏನು? I ಅಂತ ಹೇಳಿದ್ರೆ ರೋಸ್ ಎಷ್ಟನೇ ರೋದು ಆಮೇಲೆ ಎಷ್ಟನೇ ಕಾಲಮ್ಸ್. Aij ಅಂತ ಹೇಳಿದ್ರೆ this indicates that the element where it is lying, the element Aij means it means that the element is lying in the ith row and jth column. So that will indicates. ಅಂಡ್ ನೌ ಐ ಆಮ್ ಡಿಸ್ಕಸ್ ಆಮೇಲೆ ನಂತರ ಎ ಐ ಜೆ ಏನು ತೋರಿಸಿದೆ ಅಂತ ಹೇಳಿ ನಾನು. ಸೊ ಐತ್ ರೋ ಎ ಐ ಜೆ ಅಂದ್ರೆ ಐತ್ ರೋ ಮತ್ತೆ ಜೇತ್ ಕಾಲಮ್ ಅಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಎಲಿಮೆಂಟ್ ಅನ್ನ ಎ ಐ ಜೆ ಅಂತ ಹೇಳಿ ಜನರಲ್ ಆಗಿ ನಾವು ಬರೀತೇವೆ. ನೆಕ್ಸ್ಟ್ ನನ್ನ ಕಾನ್ಸೆಪ್ಟ್ ಏನಂತ ನಾನು ಏನ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತಿದ್ದೇನೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಎ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಸಪೋಸ್ ನಾನು ಎಕ್ಸಾಂಪಲ್ಸ್ ಅನ್ನ ಡಿಸ್ಕಸ್ ಮಾಡುವಾಗ ಅಥವಾ ಡೆಫಿನೇಷನ್ಸ್ ಅನ್ನ ನಾನು ಹೇಳುವಾಗ ಸಪೋಸ್ ನಾನೇನಾದ್ರೂ ಎ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಎ ಐ ಜೆ ಅಂತ ಬರೆದ್ರೆ, ಎ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಎ ಐ ಜೆ ಫಾರ್ ಐ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಜೆ ಅಂತ ಬರೆದ್ರೆ ಮೀನಿಂಗ್ ಏನಾಗಿರ್ತೈತಿ ನೀವೇನ್ ತಿಳ್ಕೊಬೇಕಂತ ಹೇಳಿದ್ರೆ, ಎಸ್ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ತಿಳ್ಕೊಳ್ಬೇಕು. ಸೊ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂದ್ರೆ ಯಾವ್ದಂತ ಹೇಳಿ, A11 A22 A33 ಕೆಲವೊಂದು ನಾವೇನಂತ ಕರಿತೇವೆ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ಕರಿತೇವೆ. ಇದು ಡಯಾಗೋನಲ್, ಇದನ್ನ ಡಯಾಗೋನಲ್ ಲೈನ್ ಅಂತ ಹೇಳಿ ನಾವು ಅರ್ಲಿಯರ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ತಿಳಿದಿರ್ತೇವೆ. ಸೊ ಇದು ಇದಾಗಿರ್ಲಿ ಅಥವಾ ಇದನ್ನ ನಾವು ಡಯಾಗೋನಲ್ ಅಂತ ಕರಿತೇವೆ. ಬಟ್ ಇಲ್ಲಿ ಈ ಕಾನ್ಸೆಪ್ಟ್ ಅಲ್ಲಿ ನಾನು ಏನ್ ಹೇಳ್ತೇನೆ, ಸೊ ಈ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ A11 A22 A33 ಇವಕ್ಕೆಲ್ಲ ನಾವೇನಂತ ಕರಿತೇವೆ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ಕರಿತೇವೆ. ಸೊ ಆಮೇಲೆ ಈ ಲೈನ್ ಅನ್ನ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಏನ್ ಲೈ ಆಗ್ತಾ ಇದಾವೆ ಆ ಲೈನ್ ಅನ್ನ ನಾವೇನಂತ ಕರಿತೇವೆ ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್ ಅಂತ ಕರಿತೇವೆ, ಅಥವಾ ನಾವೇನಂತ ಕರಿತೇವೆ ಲೀಡಿಂಗ್ ಡಯಾಗೋನಲ್ ಅಂತ ಕೂಡ ಕರಿತೇವೆ. ಇದಿಷ್ಟು ಇನ್ಫಾರ್ಮೇಶನ್ ಅನ್ನು ನಾನು ಪ್ರೀವಿಯಸ್ ವಿಡಿಯೋಸ್ ದಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದೆ, ಆದ್ರೂ ಇನ್ನೊಂದ್ಸರಿ ರಿವಿಷನ್ ಅನ್ನ ಮಾಡಿದ್ದೇನೆ. ಆಮೇಲೆ ನನಗೆ ಏನ್ ಬೇಕಾಗಿತ್ತು ಕಾನ್ಸೆಪ್ಟ್ ಏನ್ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೇನೆ, ಎ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಎ ಐ ಜೆ ಫಾರ್ ಐ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಜೆ ಅಂದ್ರೆ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ಹೇಳ್ತೇವೆ. ಯಾಕೆ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್, ಎ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಎ ಐ ಜೆ ಫಾರ್ ಐ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಜೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಸೊ ಐ ಮತ್ತೆ ಜೆ ಈಕ್ವಲ್ ಯಾವಾಗ ಆಗಿರ್ತಾವ, ಐ ಅಂಡ್ ಜೆ ಅಂದ್ರೆ ಏನು, ಐ ಅಂದ್ರೆ ಎಷ್ಟನೇ ರೋ, ಜೆ ಅಂದ್ರೆ ಎಷ್ಟನೇ ಕಾಲಮ್ ಅಲ್ಲಿ ಎಲಿಮೆಂಟ್ ಐತೆ ಅಂತ ನೋಟೇಶನ್ ಇದು, ಎ ಐ ಜೆ ಫಾರ್ ಐ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಜೆ. ಸೊ ಎ ಐ ಜೆ ಫಾರ್ ಐ ಈಕ್ವಲ್ಸ್ ಟು ಜೆ, ಐ ಮತ್ತೆ ಜೆ ವ್ಯಾಲ್ಯೂ ಎರಡು ಸೇಮ್ ಇರಬೇಕು. ಸೊ ಐ ಮತ್ತೆ ಜೆ ವ್ಯಾಲ್ಯೂ ಯಾವಾಗ ಸೇಮ್ ಇರ್ತಾವ ಅಂತ ಹೇಳಿದ್ರೆ A11 A22, ಸೊ ಯಾವಾಗ ಸೇಮ್ ಇರ್ತಾವ ಅಂತ ಹೇಳಿದ್ರೆ ಅವೇನಾದ್ರೂ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಆಗಿದ್ರೆ ಮಾತ್ರ ಐ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಜೆ ಆಗಿರ್ತೈತಿ. ಸೊ ದೇರ್ಫೋರ್ ಇದನ್ನ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ಕರೀತೇವೆ. ನೆಕ್ಸ್ಟ್ ಮೈ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ಮತ್ತೇನು, ಇಫ್ ಎ ಐ ಜೆ ಎ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಎ ಐ ಜೆ ಫಾರ್ ಐ ವ್ಯಾಲ್ಯೂ ಇಸ್ ಲೆಸ್ ದೆನ್ ಜೆ, ಐ ವ್ಯಾಲ್ಯೂ ಲೆಸ್ ದೆನ್ ಜೆ ಅಂತ ಕಳೆದ್ರೆ ನೋಡ್ರಿ ಐ ವ್ಯಾಲ್ಯೂ ಲೆಸ್ ದೆನ್ ಜೆ ಎಲ್ಲೈತಿ. ಸೊ ಇಲ್ಲಿ ಐ ವ್ಯಾಲ್ಯೂ ಇದನ್ನ ಫಸ್ಟ್ ಐ ವ್ಯಾಲ್ಯೂ ಸಬ್ಸ್ಕ್ರಿಪ್ಟ್ ಅಲ್ಲಿ ಇದನ್ನ ಐ ವ್ಯಾಲ್ಯೂ ಅಂತ ಕರಿತೀನಿ, ಜೆ ವ್ಯಾಲ್ಯೂ ಅಂತ ಕರಿತೀನಿ. ಸೊ ಐ ವ್ಯಾಲ್ಯೂ ಜೆ ಗಿಂತ ಕಡಿಮೆ ಇರಬೇಕು. ಸೊ ಐ ವ್ಯಾಲ್ಯೂ ಜೆ ಗಿಂತ ಕಡಿಮೆ ಎಲ್ಲೈತಿ, ಇಲ್ಲಿ ನೋಡ್ತೇನೆ ಐ ವ್ಯಾಲ್ಯೂ 2 ಐತಿ, ಜೆ ವ್ಯಾಲ್ಯೂ 1 ಐತಿ. ಸೊ 2 is not less than 1, 2 is not less than 1. ಸೊ ಅದಕ್ಕೆ ನಾನು ಇಲ್ಲಿ ವ್ಯಾಲ್ಯೂ ಅನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೇನೆ. ಸೊ ಇಲ್ಲಿ ವ್ಯಾಲ್ಯೂ ಅನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡಿದಾಗ ಐ ವ್ಯಾಲ್ಯೂ is less than j, j ಗಿಂತ ಕಡಿಮೆ ಐತಿ. So 1 is less than 3, 2 is less than 3. So likes go here it is. Likewise, you can observe all these elements above the principal diagonal. So principal diagonal ಮೇಲೆ ಇರತಕ್ಕಂತ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ ಯಾವ ರೀತಿ ಇರ್ತಾವು ಜನರಲ್ ಆಗಿ ಅಂತ ಹೇಳಿದ್ರೆ a is equals to aij for I value is less than j. ಇಲ್ಲಿ ಪ್ರತಿಯೊಂದು ಎಲಿಮೆಂಟ್ ಅನ್ನು ನೀವು ಅಬ್ಸರ್ವ್ ಮಾಡಬಹುದು. 3x3 ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಇರಲಿ, 2x2 ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಇರಲಿ, ನೀವು ಯಾವುದೇ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅನ್ನು ತಗೊಂಡ್ರು ಕೂಡ ಇಲ್ಲಿ ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್ ಅಬೋವ್ ಅಲ್ಲಿ ಎಲಿಮೆಂಟ್ಸ್ ಹೆಂಗಿರ್ತಾವ ಅಂತ ಹೇಳಿದ್ರೆ I value is less than j ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇರ್ತಾವು. Next condition, if a is equals to aij for I is greater than j, I is greater than j ಅಂತ ಹೇಳಿದ್ರೆ you can observe here it is. ಇಲ್ಲಿ I value j ಗಿಂತ ಜಾಸ್ತಿ ಐತಿ, ಇಲ್ಲಿ I value j ಗಿಂತ ಜಾಸ್ತಿ ಇದೆ. So ಇಲ್ಲಿ I value j ಗಿಂತ ಜಾಸ್ತಿ ಇರ್ತದೆ. So therefore a is equals to, in future if I write ನಾನೇನಾದ್ರೂ a is equals to aij for I value is greater than j ಅಂತ ಕರೆದ್ರೆ ನೀವೇನ್ ಅನ್ಕೊಳ್ಬೇಕಂತ ಹೇಳಿದ್ರೆ ಎಲಿಮೆಂಟ್ಸ್ ಬಿಲೋ ದ ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್ ಇದಾವೆ ಅಂತ ತಿಳ್ಕೊಳ್ಬೇಕು. ಸೊ ಬಿಲೋ ದ ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್ ಇದಾವೆ ಅಂತ ಹೇಳೋದ್ ಬದಲಿ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಅಥವಾ ಇನ್ ಶಾರ್ಟ್ ನಾವೇನ್ ಬರೀತೇವೆ a is equals to aij for I value is greater than j ಅಂತ ಬರೆದ್ರೆ ನಿಮಗೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗಬೇಕು. ಸೊ ಇಷ್ಟು ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನ ಬೇಕು. ಆಮೇಲೆ ಮೈ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ಹಿಯರ್ ಇಟ್ ಇಸ್. ಸೊ ಇವೆರಡು ಕೇಸ್, if a is equals to aij for I is equals to j, ಇದನ್ನ ಒಂದು ಕೇಸ್ ಅಂತ ತಗೊಳ್ತೇನೆ. ಸೊ ಇವೆರಡು ಕೇಸ್ ಕೂಡ ಯಾವ್ದ್ರಲ್ಲಿ ಬರ್ತಾವ ನೋಡ್ರಿ, ಇಲ್ಲಿ ಇವೆರಡು ಕೇಸ್ ಎದ್ರೊಳಗೆ ಬರ್ತಾವ ಅಂತ ಹೇಳಿದ್ರೆ I is not equals to j only. I is not equals to j ಅಂತ ಹೇಳಿದ್ರೆ ಈ ಕಂಡೀಷನ್, ಎರಡು ಕಂಡೀಷನ್ ಅಂಡರ್ ದಿಸ್ ಕಂಡೀಷನ್, ಯಾಕಂತ ಹೇಳಿದ್ರೆ I is less than j ಅಂದ್ರೂ I is not equals to j ಆಗಿರ್ತದೆ. ನೆಕ್ಸ್ಟ್ I is greater than j ಅಂತ ಹೇಳಿದ್ರು I value not equals to j ಆಗಿರ್ತದೆ. Is it? So therefore ನಾವೇನ್ ಹೇಳ್ಬೋದು ಇಲ್ಲಿ ಅಂತ ಹೇಳಿದ್ರೆ, ಸೊ I value ಇಲ್ಲಿ ಕೂಡ ಈಕ್ವಲ್ ಇರೋದಿಲ್ಲ, ಲೆಸ್ ದನ್ ಜೆ ಇರ್ತದೆ, ಇಲ್ಲಿ ಕೂಡ ಈಕ್ವಲ್ ಇರೋದಿಲ್ಲ, I will less greater than j ಇರ್ತದೆ. So therefore I is equals to j ಅಂದ್ರೆ diagonal elements, I is not equals to j ಅಂತ ಹೇಳಿದ್ರೆ non diagonal elements ಅಂತ ಹೇಳಿದ್ರೆ it may be the above the principal diagonal or below the principal diagonal. So therefore all elements which lies above the diagonal and below the diagonal, those all elements we can call it as non diagonal elements. So my dear students, if I write ಇದನ್ನ ಇವೆರಡನ್ನು ಮರ್ಜ್ ಮಾಡಿ ಅಥವಾ in general a is equals to aij for I not equals to j ಅಂತ ಬರೆದ್ರೆ you should understood that you should think that these are the elements which are non diagonal elements. So non diagonal elements ಅಂತ ಹೇಳಿದ್ರೇನು, so diagonal elements ಬಿಟ್ಟು ಉಳಿದೆಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನು ನಾನ್ ಡಯಾಗೋನಲ್ ಅಂತ ಕರೀತೇವೆ. ಇನ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಆಗಿ ಮತ್ತೆ ನಿಮಗೆ ಏನಾದರೂ i ಲೆಸ್ ದೆನ್ j ಅಂತ ಕೊಟ್ರೆ ಅಬೋವ್ ದ ಪ್ರಿನ್ಸಿಪಲ್ ನಾನ್ ಡಯಾಗೋನಲ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಳ್ಬೇಕು. i ವ್ಯಾಲ್ಯೂ ಇಸ್ ಗ್ರೇಟರ್ ದೆನ್ j ಅಂತ ಕೊಟ್ರೆ ಬಿಲೋ ದ ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್ ಅಂತ ಹೇಳಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಮಾಡ್ಕೊಳ್ಬೇಕು. So this is the information very important. So therefore I am explained once. So in the previous video I already explained. In the previous video ಅಲ್ಲಿ ಒಂದ್ಸರಿ ನಿಮಗೆ ಹೇಳಿದೆ, ಮತ್ತೊಂದು ಸರಿ ನಿಮಗೆ ಇನ್ನೊಂದು ಸರಿ ನಾನು ಜಸ್ಟ್ ರಿವಿಷನ್ ಮಾಡಿದೆ. So ಏನು ಹೇಳಿದೆ my dear students, a is equals to aij for i not equals j ಅಂತ ಬರೆದ್ರೆ ನಾನ್ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್. ನಾನ್ ಡಯಾಗೋನಲ್ ಅಂತ ಹೇಳಿದ್ರೆ ಯಾವ ಈ ಎಲಿಮೆಂಟ್ ಅನ್ನ ಬಿಟ್ಟು ಇಷ್ಟೇ ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನ ಬಿಟ್ಟು ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನ ಬಿಟ್ಟು ಉಳಿದ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನು ನಾನು ಏನಂತ ಕರಿತೀನಿ, ನಾನ್ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ಕರಿತೀನಿ. ಸೊ ಆಮೇಲೆ ಅದರಲ್ಲೂ ಇನ್ ಪರ್ಟಿಕ್ಯುಲರ್ i ವ್ಯಾಲ್ಯೂ ಲೆಸ್ ದೆನ್ j ಅಂತ ಹೇಳಿದ್ರೆ ಅಬೌವ್ ದ ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್, i ವ್ಯಾಲ್ಯೂ ಗ್ರೇಟರ್ ದೆನ್ j ಅಂತ ಹೇಳಿದ್ರೆ ಬಿಲೋ ದ ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗೋನಲ್ you can consider. Is it? I hope you understood. And now we will come to the types of the matrices. In that also we discussed some types of the matrices. In that first one I discussed column matrix. So my dear students, what is mean by column matrix? So column matrix means a matrix which has only one column is called as column matrix, that we discussed. And also we discussed second one, that is row matrix. So what is mean by row matrix? Row matrix means a matrix having only one row is called as row matrix. And then we discussed square matrix. So what is mean by square matrix? Square matrix means, my dear students, if a matrix in the matrix, if the number of rows is equals to number of columns, then such a matrix we can call it as the square matrix. And also we discussed after that diagonal matrix. So what is mean by diagonal matrix, my dear students? So diagonal matrix means a matrix in which non-diagonal elements are zero. Such a matrix we can call it as the diagonal matrix. Or else another one definition for the diagonal matrix is a matrix in which except diagonal elements are zero. Diagonal elements ಅನ್ನು ಬಿಟ್ಟು ಉಳಿದ ಎಲ್ಲ ನಾನ್ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಜೀರೋ ಇದ್ರೆ ಅಂತ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಗೆ ನಾವು ಏನಂತ ಕರೀತೇವೆ. And that another one condition is that should be square matrix. A square matrix in which non-diagonal elements are zero is called as diagonal matrix. So up to here we discussed in the previous video. So if you want further any doubts or if you want any information about that, means please refer my previous videos. And next in today's class I am going to discuss the next type is, that is we are discussing scalar matrix. My dear students, next type, that is scalar matrix. So as earlier I told, the diagonal matrix means what? So diagonal matrix means, here it is. So I'll write one example for the diagonal matrix. So 2 0 0 0 2 0 0 0. Is it a diagonal matrix? My dear students, my question is it a diagonal matrix? Yes, it is a diagonal matrix, because to say any matrix is a diagonal matrix, we should check two conditions. ಯಾವುದೇ ಒಂದು ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅನ್ನ ಡಯಾಗೋನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಹೇಳಬೇಕಾದ್ರೆ ನನಗೆ ಎರಡು ಕಂಡೀಷನ್ಸ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗ್ತಾ ಇರಬೇಕು. ಏನದು ಎರಡು ಕಂಡೀಷನ್ಸ್ ಅಂತ ಹೇಳಿದ್ರೆ, ಮೊದಲನೇ ಕಂಡೀಷನ್ಸ್ ದಟ್ ಆ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಏನಾಗಿರಬೇಕು, ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಆಗಿರಬೇಕು. ಸೊ ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಆಗಿತ್ತಿಲ್ಲ ನೋಡ್ರಿ. ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಆಗಬೇಕಂದ್ರೆ ಏನು, ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಹೇಳಿದ್ರೆ ನಂಬರ್ ಆಫ್ ರೋಸ್ ಮಸ್ಟ್ ಬಿ ಈಕ್ವಲ್ಸ್ ಟು ದ ನಂಬರ್ ಆಫ್ ಕಾಲಮ್ಸ್. ಸೊ ಹೌ ಮೆನಿ ರೋಸ್ ಆರ್ ದೇರ್, ಮೈ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್? 1 2 3. 3 rows are there by or cross, that I will write it as by 1 2 3. 3 rows are there, and next, my dear students, 3 columns are there. So therefore this is the square matrix. Then another one condition is that, what is that condition? Here it is. Another one condition is here, all non-diagonal elements must be zero. So this is your diagonal elements. All non-diagonal elements are zero. So therefore this is example for the diagonal matrix. Diagonal matrix. This is example for diagonal matrix. Why I am discussed means this diagonal matrix. I require this the definition in the when discussing the definition of the scalar matrix. Therefore, I am discussing this diagonal matrix that we discussed in the previous video. So diagonal matrix means what, my dear students? Diagonal matrix means a square matrix in which non-diagonal elements are zero. Then such a matrix we can call it as the diagonal matrix. This is the example for the diagonal matrix. So ಯಾವುದೇ ಒಂದು ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅನ್ನು ನಾವು ಡಯಾಗೋನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಹೇಳಬೇಕಂದ್ರೆ ಎರಡು ಕಂಡೀಷನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗ್ತಾ ಇರಬೇಕು. ಏನು ಎರಡು ಕಂಡೀಷನ್ಸ್ ಅಂತ ಹೇಳಿದ್ರೆ, ಮೊದಲನೇ ಕಂಡೀಷನ್ಸ್ ಇದು ಕೊಟ್ಟಿರೋ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಯಾವಾಗಲೂ ಏನಾಗಿರಬೇಕು, ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಆಗಿರಬೇಕು. ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂದ್ರೆ ನಂಬರ್ ಆಫ್ ರೋಸ್ ಮಸ್ಟ್ ಬಿ ಈಕ್ವಲ್ಸ್ ಟು ದ ನಂಬರ್ ಆಫ್ ಕಾಲಮ್ಸ್. ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಆಗಿರಬೇಕು. ನೆಕ್ಸ್ಟ್ ಸೆಕೆಂಡ್ ಕಂಡೀಷನ್ ಏನಾಗಿರ್ಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ, ಸೊ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಬಿಟ್ಟು ಇದೆಲ್ಲಾನು ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ಕರೀತಾರೆ. ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನ ಬಿಟ್ಟು ನಾನ್ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಎಲ್ಲಾನು ಏನಾಗಿರಬೇಕು, ಜೀರೋ ಆಗಿರಬೇಕು. ಸಚ್ ಅ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ವಿ ಕ್ಯಾನ್ ಕಾಲ್ ಇಟ್ ಆಸ್ ಅ ಡಯಾಗೋನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್. A matrix is said to be diagonal matrix if it satisfies two conditions. The first condition is that the given matrix must be a square matrix, and square matrix means what? A matrix in which number of rows is equals to number of columns. The first condition is the matrix must be the square matrix and the non-diagonal elements must be zero. Then if these two conditions satisfies, then that matrix we can call it as the diagonal matrix. So here I took one example. This is the given matrix. I have taken this example. So in this particular example, the matrix is diagonal matrix because this satisfying the two conditions. The first condition is that this is the square matrix, and another one condition is that the non-diagonal elements are zero. So therefore, my dear students, this is the example for the diagonal matrix. And now I am discussing the what is mean by the scalar matrix. So scalar matrix is nothing but a diagonal matrix. A diagonal matrix is said to be scalar matrix if all diagonal elements are equal. Then that we can call it as the scalar matrix. I'll repeat the definition. A scalar matrix is said to be a diagonal matrix is said to be scalar matrix if all diagonal elements are equal. Then such a matrix we can call it as the scalar matrix. So scalar matrix ಅಂದ್ರೆ ಏನಲ್ಲ, scalar matrix ಅಂದ್ರೆ ಏನು, ಜಸ್ಟ್ ಯಾವುದೇ ಒಂದು ಡಯಾಗೋನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಲ್ಲಿ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ ಸೇಮ್ ಇತ್ತಂದ್ರೆ, ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಎಲ್ಲ ಸೇಮ್ ಇದ್ದು ಅಂದ್ರೆ ಆ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಗೆ ನಾವು ಸ್ಕೇಲಾರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಕರಿತೇವೆ. ಸೊ ದಿಸ್ ಈಸ್ ದ ಪರ್ಫೆಕ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ದ scalar matrix because this is the diagonal matrix and all diagonal elements are same or equal. Here also 2, here also 2, here also 2. So therefore this is the example for the scalar matrix. Yes, my dear students. So scalar matrix means what? A diagonal matrix. A diagonal matrix is said to be scalar matrix if all diagonal elements are equal. So this is the one definition. A diagonal matrix is said to be scalar matrix if all diagonal elements are equal. Then that we can call it as the scalar matrix. This is the one definition. Or mathematically, or we can write another definition, that is A is equals to Aij a square matrix, or you can, this is the square matrix. A square matrix A is a scalar matrix if Aij equals to, here it is 0 for I not equals to j, and k for I equals to j. Yes, My dear students, please don't be confused. So both is same, that both are same only. So what is a scalar matrix? A diagonal matrix is said to be scalar matrix if all diagonal elements are equal. This is the one definition. Or else you can say that here it is A is equals to Aij. It is a square matrix. A square matrix. A square matrix. A is equals to Aij is scalar matrix if Aij is equals to 0 for I not equals to j. If Aij is equals to 0 for I not equals to j means what? I not equals to j. As I told here, it is I not equals to j means non-diagonal elements. The non-diagonal elements must be 0. And next, Aij is equals to k for I equals to j. For I equals j means this is the diagonal elements. The diagonal elements must be k. K may be any constant. It may be, in this particular case I have taken the 2 here. K means any constant value you can take. It may be 2, it may be 3, it may be 4. So therefore both are same, my dear students. Though only the difference is here I am writing in mathematical form. So here it is a square matrix, and please remember this is a square matrix. Square matrix A equals to Aij is scalar matrix if Aij is equals to 0 for I not equals to j, k for I is equals to j, and this is k is the some constant value, some constant you can take. So both are same definitions. Either you can use this one or you can use this one. So, is it understood? So k here it is. This is the example for the scalar matrix. And or else you can say it is a matrix, a square matrix in which all the non-diagonal elements are 0 and the diagonal elements are equal. Such a matrix you can call it as the scalar matrix. You can write like that also. So here it is. A diagonal matrix is said to be, first here it is a diagonal matrix. A diagonal matrix is said to be scalar matrix if all diagonal elements are equal. This is the one definition. Or a square matrix A is equals to Aij is scalar matrix if Aij is equals to 0 for I not equals to j, and Aij equals to k for I equals to j, where k is the any constant. This is the one definition. Or else you can say it is a square matrix having non-diagonal elements are 0 and diagonal elements are equal, then such a matrix we can call it as the scalar matrix. These are all the definitions. And example, my dear students, this is the example for the scalar matrix. Clear? And next we are going to discuss the next type. Here it is. Next type is identity matrix. I'll take here it is identity matrix. Can I erase this one? Or else I'll erase this part. So next, my dear students, we will discuss what is the mean by identity matrix. If you want, you can pause the video and write it the definitions. And please remember, my dear students, in the board examinations, while writing the definitions, please try to write the NCERT textbooks, whatever given to you the definitions, please try to write that definition. For understanding purpose, I am giving you definitions, one or more definitions I am defining here. But in particular or in examinations, in annual examination, board examinations, while writing, please write the your NCERT textbooks, whatever they given the definitions in the NCERT textbooks, please try to refer that one. And next type is here identity matrix. So identity matrix. My dear students, we discussed what is meant by scalar matrix. So here next identity matrix means a matrix in which here I can write a square matrix. A square matrix A is equals to Aij, this is of order, you can write m cross m or n cross n, because it is a square matrix. Being a square matrix, the order must be rows and column are equal. So therefore either you can write m cross n or you can write n cross n also. So here it is a square matrix. A is equals to Aij is said to be identity if Aij is equals to 1 for I equals to j and 0 for I not equals to j. So my dear students, a square matrix A is equals to Aij. I'll write this one. I'll write correct m cross m. So is said to be identity matrix if Aij is equals to 1. So what it indicates, my dear students? Aij is equals to 1 for I is equals to j. As earlier I told, Aij is equals to 1 for I equals to j. Aij for I is equals to j means what it indicates? It indicates that this is the for the diagonal elements. Is it, my dear students? Is it? So if I am writing Aij is equals to Aij, whatever value that will come to next first. Now that I will discuss before that. Aij is equal Aij for I is equals to j means you should think that this is nothing but the diagonal elements. So therefore next Aij is equals to 1 for I is equals to j means for the diagonal elements the value must be 1. In the diagonal elements the value should be 1. And next for I not equals to j. I not equals to j means this is nothing but non-diagonal elements. Here my dear students, the non-diagonal elements must be 0 and diagonal elements must be 1. Then such a matrix we can call it as the identity matrix. So the example you can take here and generally identity matrix will denote it as I. So my dear students, 1 0 0 0 1 0 0 0 1. So this is the example for the identity matrix, because a square matrix, this is a square matrix, 3 cross 3 order, it is a square matrix. A square matrix is said to be identity matrix if Aij is equals to 1 for I is equals to j. It means that diagonal elements, all the diagonal elements are 1, clear, and non-diagonal elements must be 0. These are the non-diagonal elements 0, clear. So therefore this is the example for the identity matrix. So I'll write, see here, once I'll write because I wrote double there twice. So therefore 1 0 0 0 1 0 0 0 1, clear. So this is the example for the identity matrix. And also I can take another one example, 1 0 0 1. So this is also example for the identity matrix, because all the diagonal elements are 1 and non-diagonal elements are 0. Is it? So can I define this definition as, or another one definition, my dear students, can I write it as a scalar matrix? A scalar matrix is said to be, a scalar matrix is said to be identity matrix if identity matrix if diagonal elements are equal. My dear students, a scalar matrix is said to be identity matrix if diagonal elements are equal. So no, diagonal elements are in the scalar matrix all the diagonal elements are equal only. So a scalar matrix is said to be identity matrix if the diagonal element is 1, or if the diagonal elements are 1. Is it? I am defining like this because concept is the defining way, different definitions I am giving, but the concept is diagonal elements must be 1 and remaining elements are 0. That's it. Then that should be square matrix. So I am defining different ways. Is it? And here it is, a scalar matrix is said to be identity matrix if diagonal elements are 1. So this is also same. A scalar matrix is said to be identity matrix. So scalar matrix means what I told. So in the scalar matrix, all the diagonal elements are equal. It may be 2, it may be 3, it may be 4, whatever may be the value. But those all diagonal elements must be equal. But identity means what? The all diagonal elements must be 1 only. Here this is example for the scalar matrix, and here it is. But here the diagonal elements are equal, and that may be 2, 3, whatever may be. But in the identity matrix, here the diagonal elements are 1. That should be 1 only. Then such a matrix we can call it as the identity matrix. You can call. And my dear students, please remember, for any matrix, here it is the order of the identity matrix. Generally, we will take it as I only, because here in this case the matrix is of the order 3 cross 3. In this matrix, the order of the matrix is 2 cross 2. So therefore, generally for any identity matrix, the order of the matrix n cross n. If the order is of the matrix is n cross n, I, then generally we will denote it as I only. For that is understood that if I simply write I only, so then that order should be taken a particular context. It means that if I am discussing the problems of the order 3 cross 3, then the identity matrix I should consider it as the 3 cross 3. If I am discussing the problems of the order 2 cross 2, then I should take the order as 2 cross 2. That you can also write it as, either you can write I2 like this, the order you can write, or you can write I subscript 3. I subscript 3 means what? The identity matrix of order 3 cross 3, and the I2 means what? I subscript 2 means the identity matrix of order 2 cross 2, or else simply we can write I also. So the order of the identity matrix is taken the particular context, particular situation. In that situation, how I am discussing, in which order I am taking, the discussion is going on which order, that order of the matrix, that order for the identity matrix we should take. So this is the identity matrix. And my dear students, please remember, every identity, so or else the identity matrix is a square matrix. Is it? Because 1 1 1. Is it an example for a scalar matrix? It is example for a scalar matrix. So therefore, identity matrix is a scalar matrix. Clear? That is also one note. And next we are discussing, my dear students, next one is zero matrix. So next concept is zero matrix. So next concept is, I'll erase this one. Next type is zero matrix. So zero matrix, the name itself tells that if all a square matrix in which all the elements are 0, a square matrix, the definition is if all the elements are 0, then such a matrix we can call it as the scalar matrix, and that is generally will denote by like this symbol. So therefore here it is a square matrix. A square matrix is said to be zero matrix if all elements are 0. So my dear students, a square matrix is said to be zero matrix if all elements are 0, then such a matrix we can call it as the zero matrix, and generally we will denote symbol like this. O you can call 0. So the elements will be like this: 0, 0, 0, 0, 0, 0, 0, 0, 0. So therefore, my dear students, in a square matrix, E is said to be 0 matrix if all elements are 0. And in this case also, the order of the matrix is taken particular context. If we are discussing particular context means what? If we are discussing the problems under the if we are discussing the problems, or if our discussion is going of the order of the matrix is 3, then in that case we should write like this, that is 3 rows and 3 columns, you can take 0 matrix, you can take like this. If your discussion is going of the matrix of the order 2 cross 2, in that case you can take 2 cross and 2 cross 2 matrix you can take. So that is depending upon the particular context. So therefore this is 0 matrix. So 0 matrix means if all the elements are 0, then that we can call it as the 0 matrix, you can call. So these are the main types of the matrices as per your NCERT syllabus, and beyond that some more types of the matrices are there that we are not discussing, because we are discussing here only the board syllabus purpose. And still I discuss furthermore. So those are upper triangular matrix and lower triangular matrix. So here any doubts, my dear students? I hope you don't have any doubts. So if you want to observe the examples or definitions, please pause the video, then you can read. And if you have any doubts, please comment me. Yes. And next, in Kannada I can tell this identity matrix. So identity matrix. So ಯಾವುದೇ ಒಂದು ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅನ್ನ ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಯಾವಾಗ ಹೇಳ್ತೇವೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಇಫ್ ದ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಎಲ್ಲಾನು 1 ಇತ್ತಂದ್ರೆ ಅದಕ್ಕೆ ಏನಂತ ಕರಿತೀವಿ? ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಎಲ್ಲಾನು 1 ಇರಬೇಕು, ನಾನ್ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಎಲ್ಲಾನು 0 ಇದ್ರ ಅಂತ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ನಾವು ಏನಂತ ಕರಿತೀವಿ? ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಕರಿತೇವೆ. ಆಮೇಲೆ ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅನ್ನ ನಾವು ಈ ರೀತಿ ಡಿಫೈನ್ ಮಾಡಬಹುದು, ಅಥವಾ ಇನ್ನೊಂದು ರೀತಿ ಯಾವ ರೀತಿ ಡಿಫೈನ್ ಮಾಡಬಹುದು ಅಂತ ಹೇಳಿದ್ರೆ, a scalar matrix is said to be identity matrix if diagonal elements are 1. So scalar matrix ಅಲ್ಲಿ ನಮಗೆ ಗೊತ್ತಿದೆ. scalar matrix ಅಂದ್ರೆ ಏನು ಹೇಳಿದೆ? scalar matrix ಅಂತ ಹೇಳಿದ್ರೆ, so all non diagonal elements 0 ಇರಬೇಕು, diagonal elements ಎಲ್ಲಾನು ಸೇಮ್ ಇರಬೇಕು, ಅಂದ್ರೆ ಈಕ್ವಲ್ ಇರಬೇಕು. 1 ಇರಬಹುದು, 2 ಇರಬಹುದು, 3 ಇರಬಹುದು, ಹಿಯರ್ ಏನಾದರೂ 1 2 3 ಏನಾದರೂ ಕಾನ್ಸ್ಟೆಂಟ್ k ಇರಬಹುದು. ಅದಕ್ಕೆ ನಾವು ಏನಂತ ಕರಿತೀವಿ? ಸ್ಕೇಲಾರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಕರೀತೇವೆ. ಬಟ್ ನಾನು ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇರೋದು ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಸೊ ಸ್ಕೇಲಾರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಲ್ಲಿ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಏನಾದರೂ 1 ಇತ್ತಂದ್ರೆ ಅದಕ್ಕೆ ನಾವು ಏನಂತ ಕರಿತೇವೆ? ಹಿಯರ್ ಇಟ್ ಇಸ್ ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಹೇಳಿ ಕರಿತೇವೆ. ಈ ರೀತಿ ಡಿಫೈನ್ ಮಾಡಬಹುದು ಅಥವಾ ಈ ರೀತಿ ನಾವು ಡಿಫೈನ್ ಮಾಡಬಹುದು. ಸೊ aij is equals to 1, ಅದನ್ನ ಮ್ಯಾಥಮೆಟಿಕಲ್ ಹಿಂಗೂ ಬರೆಯಬಹುದು. ಸೊ aij is equals to 1 for I is equals to j. ಸೊ ಸ್ಟಾರ್ಟಿಂಗ್ ಕ್ಲಾಸ್ ಸ್ಟಾರ್ಟ್ ಮಾಡೋದಕ್ಕೆ ಮುಂಚೆ ನಾನು ನಿಮಗೆ ಏನು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೆ ಇಲ್ಲ. ಸೊ I is equals to j ಅಂತ ಹೇಳಿದ್ರೆ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಆಗಿರ್ತೈತಿ. I not equals to j ಅಂತ ಹೇಳಿದ್ರೆ ಎರಡು ಕೇಸಲ್ಲಿ ನಾವು ಏನು ಕರಿಬಹುದು? ನಾನ್ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ಕರಿಬಹುದು. ಸೊ aij is equals to 1 ಇರಬೇಕು ವ್ಯಾಲ್ಯೂ ಯಾವಾಗ ಡಯಾಗೋನಲ್ I is equals to j ಇದ್ದಾಗ. I is equals to j ಅಂತ ಹೇಳಿದ್ರೆ ಡಯಾಗೋನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಇದ್ದಾಗ aij ವ್ಯಾಲ್ಯೂ 1 ಇರಬೇಕು, ನಾನ್ ಡಯಾಗೋನಲ್ ಇದ್ದಾಗ aij ವ್ಯಾಲ್ಯೂ 0 ಇರಬೇಕು. for I not equals to j, it means that non diagonal elements. So this is the one definition. Either you can use this one or you can use this one. So as earlier I told, so these are the different ways of the definitions I am defining, but this is for the understanding purpose. But in writing examinations, please try to write the definition whatever given to you in the NCERT textbook. That is the final definitions. Clear? Yes. Next, zero matrix means ಯಾವುದೇ ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಲ್ಲಿ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ 0 ಇದ್ರೆ ಅದಕ್ಕೆ ನಾವು ಏನಂತ ಕರಿತೀವಿ? ಜೀರೋ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಜೀರೋ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಇರಲಿ ಅಥವಾ ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಇರಲಿ, ಅದರ ಆರ್ಡರ್ ಅನ್ನು ಹೆಂಗ್ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕಂತ ಹೇಳಿದ್ರೆ ಡಿಪೆಂಡಿಂಗ್ ಅಪಾನ್ ದ ಸಿಚುವೇಶನ್. ಸೊ ಸಿನಾರಿಯೋ ಯು ಕ್ಯಾನ್ ಕಾಲ್, ಆರ್ ಡಿಪೆಂಡಿಂಗ್ ಅಪಾನ್ ದ ಕಾಂಟೆಕ್ಸ್ಟ್. ಸೊ ಏನಪ್ಪಾ ಅಂತ ಹೇಳಿದ್ರೆ, ಈಗ ನಾನೇನಾದ್ರು ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಾನೇನಾದ್ರೂ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅನ್ನ ಸಾಲ್ವ್ ಮಾಡುವಾಗ 3x3 ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ, ಆ ಕೇಸಲ್ಲಿ ನಾನು ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅನ್ನ ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಆರ್ಡರ್ ಎಷ್ಟು ತಗೋಬೇಕು? 3x3 ನ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ಬಹುದು. ಸೊ ಜೀರೋ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಲ್ಲಿ ಕೂಡ ಸೇಮ್. ಸೊ ನಾನು 3x3 ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ರೆ ನೀವು ಈ ರೀತಿ ಬರ್ಕೊಳ್ಬಹುದು. ಸೊ ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ಕಾಂಟೆಕ್ಸ್ಟ್ ವಿ ಶುಡ್ ಟೇಕ್ ಕನ್ಸಿಡರ್ ದ ಆರ್ಡರ್ ಆಫ್ ದ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಅಂಡ್ ಜನರಲಿ ನಾವು ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಆರ್ಡರ್ ಅನ್ನ I ಅಂತ ಹೇಳಿ ಬರೀತೇವೆ. ಸೊ ಆರ್ ಎಲ್ಸ್ ಇದನ್ನ ಕೆಳಗಡೆ ಸಬ್ಸ್ಕ್ರಿಪ್ಟ್ ಅಲ್ಲಿ I3 ಅಂತ ಕೂಡ ಬರೀಬಹುದು. I3 ಅಂದ್ರೆ ಏನು? ಸೊ ದಿಸ್ ಇಸ್ ದ ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಆಫ್ ಆರ್ಡರ್ 3x3. I3 ಅಂತ ಕೂಡ ಬರೀಬಹುದು, ಅಥವಾ ಸಿಂಪ್ಲಿ I ಅಂತ ಬರೀತೀವಿ. ಇಲ್ಲ, if you wanted to write the order, or else you can write it here, it is identity matrix of order 3x3 ಅಂತ ಬರೀಬಹುದು, ಅಥವಾ I subscript 3 ಅಂತ ಬರೀಬಹುದು, or else you can write in words also. So like this you can use. So these are the main types. ಇವೆಲ್ಲಾನು ಮೇನ್ ನಿಮಗೆ ಬೋರ್ಡ್ ಸಿಲೆಬಸ್ ಗೆ ಬೇಕಾಗಿರೋದು ಇಷ್ಟು ಟೈಪ್ಸ್ ಆಫ್ ದ ಮ್ಯಾಟ್ರಿಸಸ್. ಸೊ ನಮಗೆ ಜಾಸ್ತಿ ಇನ್ನೂ ತುಂಬಾ ನಿಮ್ ಟೈಪ್ಸ್ ಬರ್ತಾವ. ಸೊ ಅಪ್ಪರ್ ಟ್ರಯಾಂಗುಲರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್, ಲೋವರ್ ಟ್ರಯಾಂಗುಲರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್, and those all here it is as nilpotent matrix. So some types of matrices are still more are there that we are not discussing because this is the classes, this class is only for the board syllabus purpose I am discussing. So therefore, and but still further I am going to another two types I am going to discuss. That is, next one is upper triangular matrix. So next one is upper triangular matrix. This is not for your board syllabus. Upper triangular matrix. I'll write. Upper triangular matrix. So upper triangular matrix means, my dear students, a square matrix, Aij is equals to Aij is said to be upper triangular matrix, is said to be upper triangular matrix if Aij is equals to 0 for I greater than j. My dear students, I hope you understood. So a square matrix A is equals to Aij is said to be upper triangular matrix if Aij is equals to 0 for I value is greater than j. I value is Aij for I value is greater than j. Aij for I value is greater than j means what I told, below the principal. It means that the elements which lies below the principal diagonal. So therefore the matrix is called as, here it is, a square matrix is said to be upper triangular matrix if Aij is equals to 0 for I value is greater than j. I value is greater than j means below the principal diagonal. So in a square matrix, if the elements below the principal diagonal elements are 0, then such a matrix we can call it as the upper triangular matrix. Is it clear? So what is that? In a square matrix, here it is, if the elements below the principal diagonal are 0, then such a matrix we can call it as the upper triangular matrix. And example you can take, A is equals to 2 3 4. So my dear students, this is the example for the upper triangular matrix, because below the principal diagonal all elements are 0, then such a matrix you can call it as upper triangular matrix. That is what the condition is here. It is I wrote a square matrix A is equals to Aij is said to be upper triangular matrix if Aij is equals to 0 for I value is greater than j. I value is greater than j means below the principal diagonal. If below the principal diagonal, if all elements are 0, then such a matrix you can call it as the upper triangular matrix. And similarly we will discuss the next one, that is lower triangular matrix. So lower triangular matrix means similarly whatever I discussed. So lower triangular matrix means above the principal diagonal if all elements are 0, then such a matrix we can call it as the lower triangular matrix. So lower triangular matrix means what? So that is the reverse of that upper triangular matrix. So what is that upper triangular matrix means I told. So upper triangular matrix means a square matrix is said to be upper triangular matrix if the elements below the elements below the principal diagonal are 0, then such a matrix we can call it as the upper triangular matrix. And next, lower triangular matrix. So lower triangular matrix, lower triangular matrix. So lower triangular matrix means, again here it is a square matrix. A square matrix A is equals to Aij is said to be lower triangular matrix if Aij is equals to 0 for I value is less than j. Yes, my dear students, Aij value must be 0 for I less than j. So first we should understood I less j, Aij for I less than j means what it indicates? It indicates that above the principal diagonal. So therefore, in any square matrix, if above the principal diagonal elements are 0, then such a matrix we can call it as the lower triangular matrix. You can take example. Here it is 1 0 0 2 3 4 5 0 0. Yes, my dear students. So what is the principal diagonal? This is our principal diagonal. So above the principal diagonal, all elements are 0. That is the condition. Here it is. Lower square matrix is said to be lower triangular matrix if Aij is equal to 0 for I less than j. I less than j means this is nothing but the above the principal diagonal elements. Above the principal diagonal elements all are 0. So therefore this is example for the lower triangular matrix. And here it is below the principal diagonal all the elements are 0. This we can call it as the upper triangular matrix. So how to remember upper and lower? So upper means actually above the principal diagonal, which you may think, but that is the opposite way. So upper means below the principal diagonal value must be 0, and lower means above the principal diagonal elements are 0. Then such a matrix you can call it as the lower triangular matrix. So this is not in your syllabus, but still we discussed. In some cases we may require, so therefore I defined. So these are all the types of the matrices, my dear students. And next we will discuss, in the next class we will discuss some questions, that is all some operations on matrices, how to add the two matrices, how to subtract the two matrices, how to multiply the two matrices. That we are going to discuss, and that will discuss in the next video. Yes, I hope you understood. Still if you have any doubts you can comment me, I'll reply for that. Yes, thank you.